Good day, grade 7 learners. This is Super Mom Z, and welcome to Sci Amazing Learning Videos. Last time, we learned how to visualize motion using diagrams and graphs. Today, we will learn about waves. Are you good? Let's start. Most essential learning competency. The learners should be able to infer that waves carry energy. Hello there! Try to wave and observe the motion of your hand. Do you make a side-to-side motion? Or do you do an up and down motion? The repetitive motion that you do with your hand while waving is called a vibration. A vibration causes wave motion. Waves occur all around in the physical world. When you throw a stone into a lake, water waves spread out from the splash. When you strum the strings of a guitar, sound waves carry the sound all around you. When you swish on a light source, light waves flood the room. Water, sound, and light waves differ in important ways, but they all share the basic properties of wave motion. Now consider a boy tapping still water. He causes a disturbance created by the force applied on it. This disturbance is like an up and down movement of the water that travels away from the source. This is called a wave. A wave is a periodical disturbance that moves away from a source and carries energy with it. It is caused by vibration or force. Wave can also travel through a medium, or something that the wave can travel through. In this animation on the left, what is the medium? Right, the land is the medium of earthquake waves. How about the medium on the right? Yes, waves travel through water particles. Now let's talk about the first type of wave. In a transverse wave, particles move perpendicular to the direction of the wave while energy is being transported. The up and down movements of the hand create a series of pulses, making a waveform. On the other hand, the particles in a longitudinal wave move parallel to the direction of the wave. Each portion is alternatively compressed and extended while energy flows. Finally, a surface wave is a combination of transverse and longitudinal waves. Each water molecule moves in a circular pattern as the waves pass by. Again, here are the three types of mechanical waves: transverse, longitudinal, and surface. Remember that all of these waves carry energy, causing the movement of the particles in a medium. Let us now proceed with the parts of a wave. In a periodic wave, one pulse follows another in regular succession. A certain waveform is repeated at regular intervals. The line of origin is the original position of the medium. It is represented by the imaginary line at the middle. The highest point of a wave is called a crest, while the lowest point of the wave is called a trough. The amplitude is the maximum displacement of a vibrating particle on either side of its normal position when the wave passes. The wavelength refers to the distance between any successive identical parts of the wave. For instance, this distance from one crest to the next is equal to one full wavelength. Did you get all these 5 parts of the wave? Awesome! So why do we need to study waves? Mechanical waves such as sound, water, and earthquake waves are all important phenomena in our daily lives. Remember the 7.2 magnitude earthquake that hit Bohol in 2013? Major earthquakes like this send out transverse, longitudinal, and surface waves, which can be detected many thousands of kilometers away. Studying these waves can give us a heads up to prepare and prevent the harm it brings. Aside from this, electromagnetic waves, or waves that do not require any medium, are evident in our everyday life. We use radio waves to send information, microwaves to heat food, infrared for sensors, visible light to see, and so much more. You will learn about this kind of wave in your higher levels. Now, to check if you really understand the lesson, let us evaluate your learning. Try to answer the following questions. First, what do waves carry? Is it A, energy, B, force, C, pressure, D, vibration? Correct. The answer is A, energy. Waves carry energy, which is transferred through vibration. Next, which among these is a transverse wave? Right, this is a transverse wave. Its particles move perpendicular to the direction of the wave, while energy is being transported. How about the particles in a longitudinal wave? How do they move? Good job! The particles vibrate parallel to the direction of the wave. Now look at this wave. Which part is the highest point of the wave? Yes, number 3, or what we call the crest. Lastly, which part of the wave is referred by the number 1? Fantastic! It is the wavelength, which is the distance between any successive identical parts of the wave. Well done, grade 7 students! And that's all for our lesson on wave. Thank you for watching this Sci Amazing episode. See you again next time. Bye!